their business using technology and having better use of their cloud economics in place itself. So, for today's agenda, I will be covering software supply chain and application security, and then I will be going for the demo for like our security center. That is like your complete compliance and security posture management solution into cloud, and then I will be opening for QA. In meanwhile, if you are having any questions, you can just put your questions into chat. I will be taking it there from it. So next is like before I want to start, I want to give some, just a second. Yeah, before like starting about the application security, software supply chain, I want to give some insights about the security in software supply chain. So if you see first data, I'd say like 43% vulnerabilities are related to outdated package. And we even don't know like what packages are outdated. Second is like it just take 41 minutes to get your public port hacked into the internet, even if you are not publishing that port at all. And it takes just 15 minutes if you by mistake put your API keys into GitHub or any repo you are putting. They will be all over the world. And it is like our internal survey itself. It was done on like our this survey was done within the Google among the developer. And last is 73% vulnerabilities in the applications are due to programming errors. Lot like Docker build, like how you are building your manifest file for the Kubernetes, and then infrastructure as code if you are using Terraform or cloud specific infrastructure templates like deployment manager, or like if you are using AWS cloud formation. So any other infrastructure as a code that among like all this could contribute around 73%. And these are the figures like just gives us the insight like what are the best practices we should follow in our day-to-day practice while doing the coding. Next is like how like as a security, what is our view on the security itself in the cloud. So Google security and resilience framework, so this is like our complete stand on the security. So this is mostly aligned with the like nest CSF framework, and we have capabilities in all the 5 functions. And this is our like belief that instead of like cloud share responsibility, we should follow the shared fate. Like we are there from operation day one to the your production and after production as well. So we have like all the 5 functions, and first function is like identify. So if you want to protect, so what you want to protect, so our main goal of like in the identification is to give the clear vision of your organization critical asset and develop a plan to protect them from the failure. So what are the different things we have, like different service offering we have in cloud is like resource manager. It give you single like from a single dashboard you can get to know what is your cloud footprints, what are different assets you are having, VMs, your managed services, your service account, any keys or encryption keys, whatever the services you are using, what are the changed and what are the deleted and what are newly added. Next is like your cloud asset inventory. So it will analyze even a single like whatever things had been changed in your infra or your application, it will get highlighted in that particular dashboard. And that then next we have our like one of many services is like cloud DLP. It work as a API as well. You can integrate into your, it's not specific to cloud. You can use this at even your infrastructure or application is in another cloud. So it help you to identify and label your sensitive information, and that gives you privileges as well, whatever the things action you want to take on that particular critical information. And next we have risk manager, so it help you to identify your valuable asset and then mark the threat modeling, what will be the risk score for that particular business application, like what is the business value of that particular application. Next function we have is the protection. So main goal of protection is to stop bad actor from acting on their intent, whatever you are having. So what is our principle? Like it should be multi-layered. It is like making sure your application is always available for your intended users, and make sure your whatever the users you are having, they are not victims of the phishing attacks, and you are having whatever the data you have that is protected, whether it's in rest or in the transit. So we have different services like data protection, so even the FIPS level 2, level 3, that type of compliance also we can follow when even using our cloud specific services. Then we have one service for web, so that is web application and API protection. It includes your networking DDoS protection, your WAF, and you can have board protection as well with just one single solution. And next is like software supply chain, how you will be protecting whatever the artifacts from your developer system to the production environment. And next is like how you can make sure that whatever users you are like using the infrastructure or application, they that users are safe. So that we have different solutions into like end to end solution for the all the pillars there. Next functions we have is detect. So if any way like you have taken every measure but still your system get compromised, but how fast you can identify and make sure your security data accessible to build high detection logic. So how can you make sure that there is, and why if any data get captured, so do you have proper notification in place, to have monitoring in place. So we have services like cloud built-in monitoring for each the managed services, and your infrastructure as a service also you can configure at application level. And whatever logs you will be having, you can use BigQuery there, and from BigQuery you can run even like continuous queries, and you can build your ML model and prediction models based on your logging event as well. And for dashboards, you like your monitoring team or your executive might need a just one single dashboard to analyze your complete application posture. So you can design very like well interactive dashboards into looker as well. It's our managed BI solution. Next phase is like responding. So once you found out all the information that this VM is like compromised, I have to either delete this VM, or what I have to like remove this VM, or I have to just stop this VM. So how you will be responding for that particular issue, like incident. So that we have like complete solutions, our looker and sorry, chronicle, and our like simplify, that will help you to identify like your end to end workflow, what action need to be taken care to mitigate this issue. And once like you have your application ready, like you just spun up new VM and your application is serving, but in that particular disk you are having your critical data, how you will be recovering that data. So we have like proper plan in place that help you to identify your like whatever the your device data was there, so you can optimize, and that will be zero footprinting solution. Active Go is our one solution that help you to prevent your zero footprinting DR solution as well, and it help you to optimize your RTO within weeks, within day, and hours if you want to, like as per your business requirement. And another like very differentiated offering is like we have risk protection program. So what it can do, like if you whatever application, like that is one application is your whole solve for the your business. So you want a risk protection program if any data get compromised, but that is risk is covered by third party. So we have two partners there, you can have your partner like different partnership with them, and based on that whatever value of your data is, you will get insured for that. So next is like software supply chain. So majorly in software supply chain, it includes broken into two parts. like security of the tools and services that actually provide the environment to create the workload, like a system like your developer tools and whatever the like your IDE you are using. And second is component that makes the workload itself. That might be including your binaries, dependencies, and other open source images. So supply chain need to be implemented in such a way, like that is okay, or you are having security, but how you can ensure that whatever artifacts you are producing, that you can be verified for provenance. Like as a like in the main, I am the main authority in the production environment. How can I make sure that whatever be the like artifacts has been built by my system, that is like from built in as per my compliance policies as well. Whatever the security checks need to be taken care, are they implemented clearly? So that type of like authority and supply chain integrity should be also possible. It should be there into software supply chain. So majorly if we consider like software supply chain, so one part is like how you can make your supply secure. So make sure you are having branching and code review in place. So I like team should be encouraged to the I principle view, like at least two reviewers should be there into place. Development of code, so like that there should be branching strategy in place. Either you are going for feature specific or like specific to like your application requirement, and you are following best practices like 12 factor app, beyond 12 factor app, and ensuring that integrity of workload is delivered. So whatever phases you are capturing, there should be like metadata should be also captured, so that can verify that this is this artifact is generated by our team. And you have proper like syntax is properly followed, so linting is done properly. And you are writing like based on your criticality of the application, you are writing test as well for the when you are writing the code as well. So once you have done your code is committed to your SCM, so how you will be distributing it? So whether you have a continuous integration pipeline in place. So in distribution, you will be making your CI pipeline, and that should be like following isolated and restricted to your organization policy. Like it should be in the private VPC itself, or you want to host your build server onto your on-prem as well. And making sure like once your artifacts are built, that image scanning is done. Like in the base image you might be taking third party or open source image, so that particular vulnerability scanning is done, that there is no malware present in the software packages or base image that are incorporated into our source images. Testing, make sure you are having like static testing and dynamic testing. Like suppose you are writing Kubernetes manifest file, so in that itself you are making sure that it is not having whatever the manifest file you have written, that is not following the like high privileges SQ, like a security context is defined properly at what will be the permission of the user that will be running this. So that type of like dynamic testing need to be integrated into distribution phase itself. Now comes to the assigning trust and integrity. So for your distribution, like I already conveyed, like that authority should be there. Like this is coming from the trusted resource. And next is like in deploy phase. So that is final phase. There will be like two subcomponents here. You will be having pre-flight deployment check. So making sure that whatever images you are putting, that you can verify against a organization policy. So whatever the like images should be from this repository only, and there should be no vulnerability. If there is CVB score in this vulnerability, that image should not go to production. So that type of pre-deployment check should be there. So like in containers, we have OPA policies. You can write into Rigo language their policy, and that based on that evaluation will be done. And after that only you are allowed to execute your system into your infrastructure. And next is in the deployment itself, we cover like runtime policies. So how you are making sure that any specific standard like NIST, CIS you have to follow, that is implemented, and your host is secure as per that particular control mentioned in this compliance. Like for containers, we have network policy, and if there is compliance requirement, you might be having like a gvisor, like nested virtualization need to be used. And we have secom profile need to be activated, like should be disabled for that containers. So that is like because that are on the shared host, and you might make sure that whatever the your system is making syscalls that are not visible to the host. So that type of controlling as per your specific requirement, that is in place or not. So next is like in today's software supply chain, if this is was like complete how you will be making sure that in all the three phases, how you what are the different things are the interfaces we have. Like in today's software supply chain, if you see, there is lot of scope to surfaces to exploit. It is like over just about the overview of the delivery pipeline, like CI/CD cycle, and in particular one organization it get repeated several times, dozens of times, right? Like this, their feature velocity is too much. So these are the surfaces. Like if you see on the like first part, submit bad code itself, as you are a developer and your system is compromised, and from there you are writing code. So then he itself is like at first interface itself, your system, your complete just pipeline get breached, right? Because your first part is not secure. Second is like suppose you have SCM, and that is self-hosted git system on your data center, and that system get compromised itself. But that is not like VAPT has been not done properly, or any access like it's a user due to IAM permissions, it get hacked. So it can be have like malicious codes will be there, and whatever code will be there, that even that who is having the access, he can modify that as well. See, if you see like third one, built-in official processes, like your system was there, but code is not matching whatever the source control whatever the in the source control we have. So it can have like attacker can modify the built like your built system itself. And it can be like just example is like you are having like one example is solar winds. In there, like even your build system was compromised, and installed a like implement and like malicious code there, and in every build it was included. And if you see user bad dependency, you are using like supposing your docker images base image, you need like um, ubuntu 80 ubuntu latest. So if ubuntu latest, there are a lot of vulnerability, you are not checking that thing. So if you need like if as per best practices, you should specify particular that version which is needed for your application, and make sure that is well tested as well. That is like that is whatever the vulnerabilities CVV score is properly checked for that. So that type of things, cause like this is dependency, you are not sure that is might be having even the base image is also using another image that might have different vulnerability at all. So dependency, and even if you have your application have dependency of third party application, but how you can make sure that that third party application is built in by following best practices. Next is like your artifacts can be modified in transit. Suppose if you are using any object storage to store your like whatever the artifacts you built after your build pipeline, and somebody get access to that one, so instead of just putting your code binary, he can put any executable file there, right? And then there your code get modified, and nobody is in, even get alerted about that this code itself get modified. So in that way, and next will be like even in the your use phase is like whatever the code you are deploying into production, so is that secure or not? Like if you have deployed it, and but even if your runtime is not secure, in that itself you have given permission, root level permission into make changes into your file system, into your manifest files itself, then he can modify anything in that your application, and even user will be not able to aware about that something has changed, been some changes has been done in my application. So next is like how enterprise can secure their software supply in Google Cloud. So this is like complete our core concept we follow, that starts from zero trust and building and managing trust more and more, left and shift left in security. So it's like it should start from your development itself. It's not like I will be deploying application and before going to production I will be checking every step. So instead of this, we in like emphasize more into like you should have more towards the left. It starts from your developer system itself. So one is like our managed services. If you see from the code source repo, so these are like your managed repo. And if you have existing repo that you want to link, you can use that as GitHub or any Bitbucket repos. You can link with this cloud source repo. Then next is our cloud build. So instead of hosting your build system on the VMs where you have to manage their scaling, patching, instead of that, you should leverage the managed services where auto scaling is enabled. And most important factor is that you can create metadata that help you to validate whatever the artifacts you have built. Next is like your Google Container Registry. So once your system, like your build pipeline has created the artifacts that we have for containers, we have Container Registry. And for others, binaries, we have artifact registry as well, artifact repos. So there you can store your output from cloud build, and in that you can run on like there will be scheduled vulnerability assessment will be done, but you can run that vulnerability on demand as well. And next is like if you are deploying, you have, but as a policy check, there is like binary authorization process. So what it does, it check your images before deploying into production, that whatever things you like policies has been done. Like I have policy in my organization, I should deploy this image from this container registry only, nothing else from outside, even Google or any other as well. So is that check done before deployment? So the binary authorization does that thing. Next is your cloud deploy. So that is like your deployment pipeline. You can design your deployment pipeline. As of now, this is available for the GKE and cloud auto run in preview, and rest of services are in the pipeline as well. And then runtime, we have Kubernetes engine, your cloud run, and in that also you can run the shielded VM. Nested virtualization is also supported, and you can have detailed logging as well at your runtime. So this is like what are like this is more details about the different services that are complete part of our complete software supply chain. So if you there are some stats like 90% of organizations shows like version artifacts want to put that behind into their firewall itself. And second is some want to like most of that are like they want to run their own architecture based on the like whatever the servers they can host. So that is like they just try to leverage GitHub, Azure DevOps pipelines. But in fact, when you just talk to organization, they said that they don't want both of that because they don't have availability, so they have to go for these type of option. But if as a Google, like CI/CD, our principle is like to help organization meeting their expectation and increasing their velocity, security, and maintenance as well. So these services, cloud built and cloud deploy, both are offered as a managed services. You can run as a public endpoint. You can put that into VPC, and that VPC you can put that into service parameter as well. So if you have insider risk, that data exfiltration risk you are having, so you can put that into that service parameter. And whatever the pool you have, so based on your host you can decide the pool size, like you want to run based on the like if you are running pipeline just for 2 times a day, so you can just make cron jobs that your build server will be running on to that time. In that way you can save cost as well. and the whatever the auto scaling need to be done as per your build pipeline, that will be automatically taken care. And if you know fixed sizes, that you can leverage fixed sizes as well. And third is like hybrid pool. So you can run this into on-prem as well as a software component. So this mitigate like everything. You have your security, your operation and maintenance is less, and you have the availability and scaling on the demand as well. And this will be like your visualization. It is just like if you are using, you are most familiar with Jenkins, so they have complete dashboard. The same view you will be getting. It will be giving each build score, and it will be giving what are the different triggers when the last build was done, how much time it had taken, and what was the commit there. And based on that, like triggers, you can decide just like in the Jenkins, based on the like branches, push to your branches, based on the tags, based on the pull request, pub sub event, or any third webhook as well. And you can design very complex pipeline, like you want to have some checks, you want to give some exception for the hotfix or any other reasons. So that also you can capture. And third is like you can design like lot of like variables, different parameters. And next is like if you compare it with the deployment pipeline. So in deployment pipeline, the same your CI/CD pipeline, you will be having like approval as well. Like you want to like if this test get passed, then only it need to be go to the next phase. So you can from the pipeline itself, you can trigger the promote button, and there it will give you the detailed difference between the new version and the latest version. And in that also you can have different like logging as well. So that is like for like if you are following Jenkins, you might have to go to another tab, but in this itself within same console you will be getting detailed logging as well. Like for your build get failed and your like deployment get failed, so within that same screen you will be able to see at what step what got failed and what action need to be taken. And third phase is like if in deployment, if you are following the SRE principle, you want to create your SLOs, error budgets, so that can help you to increase your development velocity. So that captures like whatever the metrics you want to capture, you can capture that metrics with cloud build and cloud deploy and use that metrics into your SRE principle implementation. Next is like a brief about container registry. So it's act as a like central store for container images. What is best in that? You can run inside a like specific to your organization, private Google container registry. And more specific is like you can have very granular access, like who will be having access to my image and who can view that particular image, who can access, who can download, and who will be having access to the complete repo as well. And next is like within that same console, you can have vulnerability assessment. It will give you detailed assessment about that particular vulnerabilities in that image, CVV score, and you can match it to CVV database. What in that CV database, what is the next library patch that you should to implement to remediate this. So that will be like complete within one console itself you can get information. And Google has gone ahead, if I would say, into vulnerability assessment. You can we provide this in container analysis as a API, and you can include that into your existing pipeline as well. Put that image, do the qualys based analysis is done, and that analysis, whatever results you have, you can put into your other pipeline as well. We as a API, it can be exposed as well. So next is binary authorization. So if you see in binary authorization, like first where you code get, you committed your code, it goes into build system. So build system creates some metadata, like these are the test, this is the tag, this is the image version, whatever the metadata you want to build for your system. And what are the vulnerabilities we have captured, vulnerability score is there. And each phase you can have just one attester, like who will be verified that okay, this image in the build phase, it is following these guidelines. I am putting sign that it can go, and this is the metadata current state, and it can go to the next phase. Same thing will be done into the test, scan, analysis, and QA. And when it's go for the deployment into the production, so there will be like complete metadata, you will be having complete sign. And in binary authorization, I have written a policy so that whatever the tester is there, he will be checking all the metadata, and he will be just checking, oh, this image is following my policy, like whatever the organization policy guideline have. So it will be signing that, and the binary authorization will be verifying that, oh, this is following, so it is good to go for the production. If you see in the image, so if this is like our all checks, whatever the checks has been there, it is passed, then binary authorization is approving that. And if somebody try to put that, like if in that my policy I have written the image, like ngx image should be not deployed, and in test or any other image should be not deployed, I have just complete repo url that should be only allowed. So even you are admin there or in GKE or whatever access you have, you can't deploy that. So that is like without a, like you are not checking anything, and your production is secure itself. So it's help you into that authorization as well. And there will be like whatever logging you have, suppose anybody try to do that, whatever, like if anybody has tried to deploy any test containers or any other thing, so whatever that process you have and binary authorization is enabled on your your GKE, so it will capture whatever the failure has been done into your cloud audit logs. So cloud audit log you can use for the forensic as well, like if there is an auditor requirement there, and for that you can show it like this is the data what has been changed in my system. And secondly, you can know, you will be getting like who is trying to get that, so you can block that user or block that IP. If you know that system is accessing this, you can take preventive action against that. And another best is like you can create a policy, binary policy in allow all, deny all, and even customization also. And customization is like suppose there is an hotfix need to be deployed and you want exception for that, so that type of exception also you can capture into binary authorization. So next I want to give an idea about like security command center. So it is our cloud security and posture management solution, and it map all functions into our whatever the security framework we have, like all 5 functions starting from detect to the recover phase. And what it does, it gives you center visibility into your whatever the your infrastructure you are having, or whatever the resource, whether it's identity or your platform. And next is like it help you to find out and fix vulnerabilities and risky misconfiguration, like suppose any service account keys are having high privileges. If your security account itself has a high privileges and that is not even used, it help you to detect targeting your Google Cloud asset. So whatever threat, so it will be your platform, like your VMs, GKE, App Engine. So it will help. Threat analysis is done. It is like just baseline and based off like at OS level, it is done. So it will be giving like this is whatever the vulnerabilities in this OS it have, and even it's like it you can take action without like even notifying at the your particular VM level. You don't have to install agent for that. And for your identity, so for users it will be like even behavior analysis done. If you have your cloud identity and user are there, suppose any user in the group try to accessing or behaving like anomaly is there, behavior anomaly is there, it will highlight that one as well. And next is like suppose you have compliance that you have to follow, but how can you make sure, because in cloud there are different like security, database, and you have identity. So how you can make sure that whatever controls need to be taken care, you are following that or not. So this is like complete your security posture management solution. So next is our web solution. That is like how you will, once you have deployed to your runtime, how you will be protecting at your network layer. Suppose how you will be protecting your application from the web application firewall, how you will be protecting your application from the bots, how you will be protecting your application from the your DDoS layer at TCP layer and TCP layer 3 and TCP layer 4, and then how you will be protecting your APIs misuse, like I mean like based on like when user is behaving, and even whatever the rate and quota you have configured, if you have different partners, so how you can make sure that is secure, because that is part of your availability as well. So WAP is term coined by the Gartner. So it help is like web application and API protection. So first phase will be like our, this is our complete solution. Like these are different three managed services, but club, it can be integrated, they can individually also you can use, and as a combined solution also the integration is possible. So cloud armor, so this is like your complete DDoS attack, TCP layer 3, TCP layer 4, and then it has like WAF top WASP attacks you can mitigate. And there you can have like whatever the geographic, like suppose you have specific compliance, like your application need to be just available to India user only, that type of control also you can put. And your recaptcha is our fraud and bot protection capability, and it is the same service that we Google is protecting their system. APZ, like our standard API platform, there you can have management of your entire life cycle, development and the operation, as well as the security itself. So brief about Cloud Armor. So Cloud Armor is like full-fledged web application firewall. So there you can have the backend policies as well. Backend policies, like suppose you're protecting your backend server, and there is as policy. If suppose you have CD, your whatever the like cloud buckets is having lot of objects, like you are using CDN. So how you will be protecting your objects or CDN there? So you can put the as policies there itself, like from which location it will be used, and specific IP only you are allowing access. And in the WAF itself, if you see the its networking layer protection is like TCP sync, that is around 80% contributor into DDoS attack, you see. And it's suppose like any other protocol attack also, like TCP, any other ports that are available for attacks. Allow and block traffic, so it based on IP specific, and you can define the named IP as well. And geographies and custom match parameters. Custom match parameter is specific to an header, or specific any request. In request we have header, then only allow this traffic. And then there is like telemetry, so built in like whatever policies you have, if suppose my access is allowed, so that will be captured into log, so based on that you can take preventive action. And that we have adaptive protection. So adaptive protection is very like ML based machine learning is implemented for security. It will be having a baseline running, and that after that 1 hour baseline, it will give you, it will flag out anomaly behavior. If suppose any user is trying different access behavior is observed in my application, it will highlight that, and it will help me to find out like what action I have to take to mitigate this. And this is reCAPTCHA. So this is invented by Google, and this is part of version 3. There you can integrate within your system with the like itself into your code. And there are two types of like models we support. One is like specific to URL, and one is complete session itself for the one particular user. And it help you to define like you want to take action, you want to deny it, or you can define like any second factor authentication you want to take on that. So that is also possible. And it gives you a risk score like 0 to 1. 0 is like that is like bot, and 1 is like authenticated user, and based on that there are 11 levels you can optimize as per your business requirement. Next is APZ. So securing your API, And governing access. So governing access is like you bundle your API into product, and based on your requirement, different partner agreement, you can publish that as a product itself. Your API analytics, based on that, you can take action. What I need to do, that is built in into into console itself, that you can analyze what is the behavior of that whatever the API has requested. And it is integrated service, like the same service you can leverage, like cloud IAM you can use, like who will be having developer access, who will be having the like portal access, who can expose API, who can create products. So that type of integration is also possible. And next is you can have the cloud logging enabled. Whatever the access or request get captured, you can that same into your logging as well. And this is complete portfolio of the Google security services. It map into every field, like whenever you encounter security, whether it's identity, application, your data security, your network security, and the endpoint security. Endpoint might be including your device management, your Chromebook, or like whatever the browser even systems are using. Now I am just starting the demo. So just a second, let me switch the tab. So this is, I think, if you are most of you are will should be familiar with this. So this is Cloud Console. So whenever you enable your cloud account, so you will be able to see this screen. So there itself in the hamburger menu, you have different services that you can choose. If you go to this navigation menu, there will be different categories. Like if you see, these are like different products, like marketplace, billing. And in that also, if you go to this in different like database, what are different offering we have, serverless, what are different offering we have, then we have compute and networking operations. So it will be like detailed as per the like different categories. We have generalization of the product. So this is our security center, command center. This is complete security compliance and posture management solution. So if I go there, then it will give me a detailed view. So your team, operation team or SOC team can use this board to find out your complete posture of your cloud presence, Google Cloud presence, specific to Google. So this will give you whatever the like vulnerabilities you are having based on the date, severity, and as per your like different findings, and findings specific to resource. These are different categories like OWASP, or like you are specific to your networking, specific to your resource, specific to like event based analysis is also done, container based specific analysis, threat analysis also finding, you will be finding to finding itself. Then like first phase is like asset. So it will give you complete idea about whatever asset I have. So it have like I have around this added, active and removed. So based on day to day basis, you can monitor your whatever the assets you have into your cloud. And then it's give to whatever the vulnerabilities you are having in system, vulnerability as the compute, vulnerability at the container level itself. So it will give you specific to your this like suppose if this is open RDP port, right? So this is networking related vulnerability, and it give me your which resource is not complying. That when you open this, you will be able to see and what things you have to correct it to capture, like remove it from here. And then XSS, your like whatever the like SQL injection, remote site code and execution is there. So it will give you everything there. SSL is not enforced. If you are using key management solution, your keys is having high keys are exposed, and you have not enabled key rotation. So everything is captured here, except whatever the resource you have that might be cause an incident in your system, that are captured here. And then based on your threats, will be capturing your infrastructure threats, like whatever, like VM is having OS level vulnerabilities, and then container level vulnerabilities, like any binary has been executed into your container, and specific high privileges, suppose your root system file system was exist in your container. So that type of vulnerabilities, like with that type of threats, events get highlighted here itself for the your VM compute engine and your container as well. And next gives to your complete finding whatever things like you are having specific to your resource wise, like in this resource whatever the findings we have, and that you can classify it's like threats and that are like vulnerabilities there, and you want to capture it as a security like severity wise, so that will be also get highlighted itself. And if you see this is like set security marks, so if there is like very business critical application and you want to take immediate action, so you can just mark it as, and based on that your whatever operation team like the SOC level 1 team can take and initiate the next incident process into place, like it this should be fixed. So whatever the incident commander will be there, then he can define who will be resolving this and assigning this. And next is like your source. So whatever source, like source is like if you check the resource hierarchy into GCP, so that will give you like this is the organization. Under organization you have different folders, and folders you can have specific to your application, or you can have specific to your business segmentation as well. Like if you have different business unit, that type of same governance structure you can follow into GCP as well. And you can get that at that project level. Like suppose you are one person is responsible for the production environment, so they can just filter out their production environment. And another is sources, like suppose you have third party endpoint system. So third point endpoint system is like you have CrowdStrike enabled on that, and you want to capture whatever the events they have. So you want to put that finding into here and just show into as per other resources as well. Like in compute, you are using Google Cloud Compute Engine, but you have CrowdStrike as a endpoint protection. So that logs will be ingested here, and on that finding as well, it will give you what are the threats and vulnerabilities into that particular logs. And it have like lot of connectors you can put that into your identity provider. You can have your endpoint protection. And third is like once you have this, you if you have SIM and SOC in place, you can integrate that from here itself. Like if you go here and in explore, there will be one setting there you can just export to third party. So it can be your third party SIMs and source solution, or you can just export to one event like PubSub event, and based on that you can define the action. Suppose I found like one identity is behaving and behavior is anomalous. Like today I am logging from India, and tomorrow morning itself it found like I'm logging from US. So that is a behavior anomaly, right? So it should be highlighted, and based on that highlighted, what a security command center can do. So there you will be having exporting that particular event to cloud PubSub, and on that action cloud PubSub event, you can define one cloud functions or any other action you want to take. I want to remove this user, or I want to enable multi-factor authentication for that guy. So that type of flow you can design itself. And next feature, like compliance. So what you can do, like it will give you complete dashboard. There you can see different controls. Like for if you check with this specific compliance, there are like 250 controls that are applicable to cloud, and I am just passing 78. And if I go to complete recommendation, it will give me what are the different compliance that I am not following. And CIS, like most of the cloud provider are having compliance with the CIS, so it will give into each category what we are enabled and what we are failing, and which resource, if you open it, it will give you like which resource are not as per the compliance, like PCI DSS. That is like in fintech, if you see, this is most followed compliance. So but here itself you don't need any auditor. Before auditor you can make sure like, oh, 19 controls are applicable in cloud, and in where I am passing, where I'm failing, and what I need to take care. Then once you have 19 out of 19 enable, you can go to auditor. That makes your compliance get easy as well. You have NIST, ISO, OWASP, and we are continuously adding as per the customer demands as well. So I am done. I am open for question answers. Sorry, it's just 5 minutes, but we can go with questions now. Anyone have any question regarding anything?
So now you have the option to unmute yourself and ask your questions, so you can do so if you have any questions. Hi James, I'm sorry that this session I know you joined late. So what we'll be doing is we have recorded this session, so we will email that to you, and if that should help you, I suppose.
So any other queries you are having?